This video is going to talk about random variables. A random variable is a variable or a process that has a numerical outcome. For example, if I flip 2 coins simultaneously, that's a random process. If I count the number of those coins that land with heads facing up and let x equal that number, then x is a random variable. A probability distribution lists all of the possible values of a random variable and their associated probabilities. In our example of the 2 coin flips, where x was the number of those coins that landed with heads facing up, the possible outcomes are 0, 1, and 2. We use the small letter x to represent the actual values that might be realized. And remember, the capital letter X is sort of like the random quantity. And so we talk about the probability that our random quantity, x, big X, takes on the value equal to little x. And we have the probabilities shown here. Note that because we are listing all of the possible outcomes and their associated probabilities, that the probabilities in a distribution must always sum to 1. The expected value of a random variable, which we use the notation mu to denote, is the average or mean outcome of that random variable. To find the expected value, we take each of the possible values, little x, and multiply it by its associated probability, and then we add up all of those products. So for our coin flipping example, looking at the number of heads facing up in 2 coin flips, we find the expected value of x by taking 0 times its probability 0.25 plus 1 times 1's probability 0.5 plus 2 times 2's probability 0.25, and that gives us an expected value or a mean of mu equals 1. We can also measure variability, that is how variable the outcomes of a random variable are. We have 2 different ways of measuring this. One is using the variance of the random variable, and the other is using the standard deviation. To calculate the variance, we are measuring how variable the outcomes are around the expected value, and we do this by taking each possible outcome x, subtracting the mean, and then squaring that deviation, and then multiplying the squared deviation by the probability of the outcome little x, and adding those all up. The standard deviation is just the square root of the variance, so if we want to calculate our variance from our coin flipping example, can apply this formula as shown on the slide to find both the mean and the standard deviation. Next, we'll talk about linear combination of random variables. These are written in the form a times x plus b times y, where x and y are 2 random variables, and a and b are 2 known numerical quantities. For example, if x is the number of apples in a 3-pound bag, and y is the number of oranges in a 5-pound bag, a Girl Scout troop purchases 1 randomly selected bag of each type of fruit, and they're planning to sell the apples for 50 cents each and the oranges for $1. The total income from selling all of the fruit is going to be 50 cents times the number of apples in the bag, plus $1 times the number of oranges in the 5-pound bag. Because the linear combination a times x plus b times y is a random variable itself, we can calculate its expected value, which we do by taking a times the expected value of x plus b times the expected value of y. In our example, x was the number of apples in a 3-pound bag, and that random variable would have some sort of expected value. Here we'll assume that that expected value is 12. And y, the number of oranges in a 5-pound bag, will also have an expected value, which we'll assume for the sake of this example is 15. Now if we want to find the expected total income for selling all of the fruit, we take 50 cents times the expected value of X, that's 12, plus $1 times the expected value of Y, that's 15. And so our expected total income from selling all the fruit is $21. We can also find the variance of our linear combination AX plus BY. To find the variance, we take A squared times the variance of X plus B squared times the variance of Y. If the variance of the number of apples in a 3-pound bag is equal to 4, and the variance of the number of oranges in a 5-pound bag is equal to 5, then the variance for the total income from selling all of the fruit is going to be 50 cents squared times 4, which is the variance of X, plus $1 squared times 5, which is the variance of Y, which gives us 6. Now note that because the units here, we squared the dollars, the variance has units that are $6 squared is the variance. If we wanted to have a measure of variability that it was in the units dollars, we could use the standard deviation and take the square root of the whole thing. I hope this video has helped you get started working with random variables. Have a good day.